So let us now look at some of the calculations in a parallel connection. So the first thing that we said under parallel connection, we said that the voltage is always the same. So here the most important thing that you must know is that voltage is the same flowing through all the components in a parallel connection. Then since voltage is the same here, for us to find the total current, we are going to add our current 1 plus our current 2 plus our current 3 plus, if there is more, you're going to add more, plus your current 4 plus your current 5 if you have more current there. Then for you to find the total resistance, so there are two formulas that we use when finding the total resistance. You can either use total resistance. So there are two formulas. You can either use this one. So 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So you can continue adding if you have more resistance. Then you can also use this one. You can also say your total resistance is equal to the product of the resistance divided by the sum. So we can say R1 multiplied by R2 multiplied by R3 divided by R1 plus R2 plus R3. So these two formulas, this one and this one, they give the same answer. So you can use one, and let us do some of the simple calculations. And for this calculation, if we have this circuit in this form, so if this is the resistor and this is the resistor, and here the current that is flowing is 2 amps and the current that is flowing here is 3 amps, and you have been told to calculate the total current. And as you can see, this is a parallel connection. So for us to calculate total current, we're going to say current 1 plus current 2. So our current 1, that's 2, plus our current 2, that's 3. So our answer is going to be 5 amps. Let us look at another example. So for this example, as you can see, we have two resistors. So here the resistor reads 2 ohms and here it reads 4 ohms, and the electromotive force that is coming from the battery is 8 volts. And if you have been told to calculate current there, we can calculate the current. So you can calculate the current that is flowing through this resistor. So we can say our first current is equal to voltage divided by resistance, and we know that voltage is always the same in a parallel connection, so that's going to be 8 divided by 2, and 8 divided by 2, that's 4 amps. And for us to calculate our current 2, we're going to say voltage divided by resistance. Our voltage is always the same, so we're going to use 8 volts divided by our resistance 2 here. This was resistance 1, sorry, and this is resistance 2. Resistance 2 there is 4, so that's 2 amps. And for us to calculate our total current there, we're going to add current 1 plus current 2. So that is going to be 4 amps plus 2 amps. Our answer is going to be 6 amps. So from from these all calculations, we can say for us to calculate our total current, if you have been given this setup, we can just say voltage divided by resistance 1 plus voltage divided by resistance 2. So that's the other formula that you can use. Let us look on how you can calculate the total resistance in a parallel connection. So with the total resistance, I gave 2 formulas. I said you can use this one. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Or you can use this one, where you say the product of the resistors divided by their sum. And for example, if you have this setup, so if you have this setup and you have been told to calculate the total resistance there, we know that we say 1 over RT is equal to 1 over resistance 1 plus 1 over resistance 2. So that's going to be 1 over RT is equal to 1 over our resistance 1, that's 2, plus 1 over our resistance 2, that's 3. So that's going to be we can find our lowest common denominator there. Our lowest common denominator, that's 6. So 2 into 6, that's 3, plus 3 into 6, that's 2 into 6, that's 3 multiplied by 1, that's 3. Then 3 into 6, that's 2 multiplied by 1, that's 2. So as you can see, we are going to have 3 plus 2 is 5 divided by, that's going to be divided by 6. And from this we can say we can close multiply here, and if we close multiply, we're going to have RT multiplied by 5. So we're going to have 5 RT is equal to 6 multiplied by 1, that's 6. So for me to calculate the total resistance, divide by 5 here, divide by 5. So I'll say my total resistance is going to be 6 divided by 5. So let us prove it by using the other formula that I had given. So the other formula, we're going to say total resistance goes to, we're going to multiply, divide by the sum. So resistance 1 multiplied by resistance 2 divided by resistance 1 plus resistance 2. So resistance 1, we know that's 2 multiplied by 3 divided by 2 plus 3. So here I'm going to have 2 multiplied by 3, that's 6, divided by, so this is ohms, divided by 2 plus 3, that's 5 ohms. So as you can see, this answer and that answer is the same. So you can decide on your own which formula that you want to use. Let us look at another instance. If you have a combination of parallel and series connection, then 2 ohms here, then I have 3 ohms, I have 1 ohm, I have 2 ohms here. And if I've been told to calculate the total resistance here, so I have two types of connections here. So 2 ohms and 3 ohms, they are connected in series, as you can see, and 1 ohm and 2 ohms, they are connected in what? In parallel. So for this, we can add this one and this one, since these are in series. And in series, we know that you get your total resistance by saying R1 plus R2. So this is going to be 2 ohms plus 3 ohms, and that's 5 ohms. And since we know that this is in what? In that's in what? In parallel connection. So I can just use this formula. I can say total resistance goes to resistance 1 multiplied by resistance 2 divided by resistance 1 plus resistance 2. So that's going to be 1 multiplied by 2 divided by 1 plus 2. So 1 multiplied by 2, that's 2 divided by 1 plus 2, that's 3. And if I use the calculator there, I'm going to have 0.7 ohms if I round off to 1 decimal place. And for me to calculate the total resistance for this circuit, I'll just say 5 ohms that I had calculated at first plus 0.7 ohms. So my total resistance there is going to be 5.7 ohms. So those are some of the calculations that you can do under parallel connection. Where you have questions, you can ask in the group. Let us now look at the cost of electricity. So as you know, the electricity that we use in our homes, we pay for it. And here in Zambia, we use ZESCO. And if you have been given the ZESCO units, the units, they're going to be in kilowatts hour. So these are the units of electricity, and you need to pay for them. And we know that from our previous formula, we said power is equal to energy divided by time. And since we defined power is equals to the rate of work done, and from this we can say the units of energy there, it's the units of energy is joule divided by the units of time there, it's second. So that's going to be joule per second. So we can say the watts there are equal to joule per second. So let us proceed. So we also know that we can use the formula here when we make E the subject of the formula there. So we are going to say E is equal to power multiplied by time there, and from this we can also say 1 kilowatt hour is equal to, since this is watts, and 1 kilowatt is equals to 1000 watts, so this is going to be 1000 watts multiplied by time, since it's in hours there. We know that when we convert 1 hour to seconds, we are going to have 3600 seconds. And if we do our calculations there, when you multiply, you're going to have 3,600,000. So you're going to have 3,600,000 watt. That's going to be watt seconds. And since we have that, then we know that our watt per second here. So from this formula, we know that this is watt, isn't it? And when we multiply it by time, so we're going to have watt seconds. So we can also say that 1 joule is equal to 1 watt 1 watt seconds there. And since we have done that, so we know that that's 3,600,000, and if we cancel out the zeros there, we're going to have 3600 kilojoules. So we know that 1 kilowatt hour is equal to 3600 kilojoules. So at Just Production, we provide the following services. We sell some past papers with answers. And the past papers that we have 2017, 2018, 2019, and 2020. And these past papers, you can get them at both hard copy and soft copy. For the soft copies, they are only going at 20 kwacha per paper. So that means if you want paper 1 for 2020, you just pay a 20 kwacha. And after you pay 20 kwacha using Airtel or MTN mobile money, we are going to send it on WhatsApp. Then if you want a hard copy, it is free delivery within Mandef constituency, or we can deliver in town, we can meet in town, and I can give you that hard copy. Then the other service that we provide are Just Productions, that we provide online tuitions. And for the online tuitions, we provide subjects like physics, chemistry, math, and biology. And the price is only 100 kwacha per subject. And for instance, if you want to be learning mathematics, you just pay 100 kwacha, and you are going to be added to a WhatsApp group. And in those WhatsApp group, we actually post videos on a particular topic, and where you have questions, you can ask in the group. So that's how the online tuitions work. So it's 100 kwacha per month, and that's per subject. Then we also sell some books. We sell books for all the grades from grade 10 to grade 12. And these books include for physics, chemistry, math, and biology. And the price is only 10 kwacha per subject, and that's soft copy. And for the hard copies, it's only 25 kwacha. So for further information, you can call me or text me on the number that is showing on the screen, which is 0973023620. Peace. God bless you. full topic of current electricity is available and it's only going for sale at 10 kwacha. And after you make a payment using Airtel or MTN mobile money, I'm going to send the video on WhatsApp, and this video includes the following: electrical symbols, current, quantity of charge, direction of current, potential difference, electromotive force, electrical energy, power, electrical resistance, the circuit, series connection, parallel connection, cost of electricity, the 3-pin plug, the fuse.